Hello students, welcome to day 13 of Mathematical Theory of Interest course. In this session we will discuss about the loan repayment. And this topic we will discuss today and in the next class, in tomorrow's class. We have already discussed this topic in previous week's classes when we have talked about the loan amortization. Today we will discuss this topic in depth details. We will discuss more in depth characteristics of loan amortization schedule in details. So quickly moving on to our lecture. We already know what is loan amortization schedule. I will give you a brief overview of loan amortization schedule. Loan amortization schedule is basically a table which is showing how to repay your loan. Like when we have taken a loan, we have to make a fixed payments of that loan, and in fixed installments or fixed payments we are supposed to pay the interest as well as the principal amount, and in the final payment everything will be paid and your balance of your loan amount will be zero. So in loan amortization schedule we will calculate how much we will actually segregate the interest portion and the principal portion in each installment, and we will find out how much is the balance in your principal amount goes after making payment, after making every installment. So in short we can say that a loan amortization schedule is basically a table which is showing how the payments of the loan is being segregated in the interest payments as well as in the principal payments, and it tells us in detail workings of the payments of loan. So an amortization schedule represents the total payments, interest, principal and outstanding balance in each period. I already discussed with you. So it can be created with a financial calculator, or we can make it by using a spreadsheet with Excel, MS Excel. So here are different functions that we will use while preparing the loan amortization schedule. There are three basic functions that we need to use. First of all, we need to calculate the payment. For that purpose, we need to we are required to have rate, interest rate, and per present value, future value, and the type of this particular loan, whether it follows an ordinary annuity payments or whether it will follow annuity due type. We are required to calculate the total payment, principal amount, interest, including the principal plus interest payable for the compounding period. Then we need to calculate the PMT, which is the principal payment payable for that compound period, and we need to calculate IPMT, the interest payment. So these are the three main things that we need. What is the PMT? PMT is the total payment. Then we divide it into two portions. First is the PPMT, second one is the IPMT, the principal amount portion and the interest payment portion. The combination, if we add up IPMT and PPMT, then it will give us the PMT answer. Furthermore, we need the rate, which is the rate of interest. Then we need N per, it is the total number of compounding periods. N per is the total number of compounding periods. Then we need to calculate the present value of the loan. FV is the loan amounts outstanding after all payments have been made. It must be zero. Then lastly, we need to calculate whether it is an ordinary annuity or whether it is an annuity due. Why we need this one? We need to decide whether the first payment will have either 0 value or 1 value. If the payments are made are due at the end of each period, then by default we will consider, if no other information is given to us in the question, we will consider that the payments are made at the end of every time period. Then the value will be, value of per will be, and per value of then the value of the type will be 0. And if the payments are made at the start of, are due at the beginning of every period, then the value will be, the value of type will be 1. So it means 0 refer to ordinary annuity type and 1 refer to annuity due type. Annuity due type, remember. Now for PPMT and IPMT, there is the additional variable per, which is the period. Per is the total time period, the particular compounding period for which you want to find the interest or the principal payable. Now let's start about creating the loan amortization schedule. For the rest of the cases, we will need to calculate the compounding period, which is actually the frequency in which the outstanding loan amount is calculated. For the purpose of this exercise, we will assume the most common sense of using the monthly payments. So total time payment periods in each year will be 12. Will be added 12. So here is an example to get a more clear understanding about the loan amortization schedule. So in this example, we will prepare thoroughly the loan amortization schedule. The total compounding period is monthly, so in every year there will be total 12 payments. Total amount of loan is 1 million. Loan duration will be lasted for 30 years, and interest payment is 3% per annum for the first year and 5% per annum after these years. So we will enter this information in our Excel sheet. As first of all, we need to make this table. Total loan amount is about, we need to write down the details. The loan amount is 1 million. Loan duration is 30. So in every year total 12 payments will be made. So 12 multiplied by 30, it will be the total time payments will be 360. Interest per annum will be 30. Nominal monthly interest rate is, if we will divide it, the per annum mean annual interest is 3%, and because the compounding periods are monthly, on monthly basis, so we will divide it with 12. So the nominal monthly interest rate will be 0.025. So as this is the explanation. This is the explanation. Because the frequency in which the outstanding loan is calculated once a month, the number of compounding periods each year is 12. So the total compounding period for 30 years will be 30 multiplied by 12, it will be 360. And the compounding period is done for 12 times every year. Every year the nominal monthly interest rate will be 3% divided by 12, and it will be 0.025. Now moving further, for the 0 time period, we are not making any time payment. We are assuming that this is an ordinary annuity. The value will be start from 0. So at the first time period, we will calculate its payment value by using the ordinary annuity formula that we have discussed in last week. By using this formula, you can calculate the monthly payment, equal payment, which you have already done. I have you must calculate this payment by yourself. Here we will discuss loan amortization schedule. So the first payment is $4,216.04. In $4,216.04, we are paying principal amount as well as the interest payments. Interest amount is 0.025. 0.0025 multiply by 1 million will give you us the 2500. So in total payment, the interest payment is 2500. Remaining, we will minus 2500 from 4216.04. Remaining 1716.04 will be your principal payment. Will be the principal payment in the first transaction. So we will deduct this principal payment from our loan amount, which is 1 million. So we will deduct 1716.04 from 1 million, and the answer will be 998,283.96. It will be remaining loan balance, principal amount of loan that is due. And we will continue this procedure till 360th payment. We will need to make use of the functions to obtain the payment principal, payments, principal, interest, and the balance. And we will make our calculation and drag down the whole process. The formulas will automatically be generated. Formulas will automatically be generated. This is the how we can calculate the principal payment, the payment, IPMT, PMT. These are the formulas you will use to calculate. These are the formulas you will use to calculate all these values. These values will be automatically generated by using these formulas. And once you have insert these values for the one time, then you just need to drag, select, and drag down. All remaining values will be automatically calculated. All these remaining values will be automatically generated. So this is the beauty of using this MS Excel spreadsheet. This is how you can easily make the payments for the first year. You can easily calculate the payments for first year. So after finding the amortization schedule for the first year, what will be the second year? We set up a new amortization schedule with different values as below. We need to calculate the new values. So in the second year, the loan amount will be 9,79,122. Now loan duration will be 29, and total periods will be 348, and the interest payment will be 5%. Because in the first year the interest rate was different. Now after second year the interest rate is 5%. We will convert this interest rate by dividing it with 12. The new interest rate will be 0.0041667. Again, we will use the previous concept to know the we will use the same procedure that we have done for the first year payments. From the second year till 348th payment, we will use this table. So we will insert the loan details, then we will use these previous commands that we will discuss in the previously to draw the table, and then we will drag out the whole table till 348th payment. That will give us the complete loan amortization schedule. So in this table, the odd thing that we have observed, that with the passage of time, after every payment, the principal payment PPMT will increase and IPMT will decrease over the time period. Why? What is the reason behind that? Because IPMT will always be calculated on the balance amount, on the principal amount. As the balance amount is decreasing, so the value of the interest payment will also decrease. If the value of interest will decrease, the PPMT will also will increase. PPMT will increase. This is the reason behind that. You must remember this reason. At the 348th period, the loan is completely paid off, so the balance outstanding loan will be $0. So you can just use this concept You can use the same values to practice loan amortization schedule by yourself at home. I will strongly suggest you to practice this table at least 3 times. At least 3 times. So this is all about our today's discussion. In tomorrow's class is basically in tomorrow's class we will practice this loan amortization schedule. We will have more practice about the loan amortization schedule. For better understanding of tomorrow's class, I will strongly suggest you to go through this lecture, day 13's lecture, in detail and practice these two examples by yourself at least 3 times at home. First of all, by using the same values, and the second and third time by using the different values, so that you will have more clear and better understanding about this concept. See you in the next class for a practice session. See you. Bye bye.